Good morning, students. Welcome back to chemistry class. In this session, I'm going to mark the book back questions for the third unit, periodic classification of elements, and the remaining of fourth unit questions. Today, I'm going to mark because most of you asked me in YouTube class, I should mark the question answer. That's why today I'm going to mark the book back question answer. So, in last class we completed the unit number 4, question number 38. Okay, up to question number 38 we completed. And today, question number 39. Question number 39. An isotope of hydrogen A reacts with diatomic molecule of element which occupies group number 16 and period number 2 to give compound B. Here, isotope of hydrogen A. It reacts with diatomic molecule of element which occupy group number 16 and period number 2. Group number 16, period number 2, which element? Here listen, page number 70. For having the periodic table, listen here. Group number 16 and period number 2. Second period, 16 group, which element present here? Oxygen. Okay. So when oxygen react with isotope of hydrogen. Isotope of hydrogen means deuterium. Okay, deuterium to give the compound B, that is used as the moderator nuclear reactor. You know the which substance is used to moderator in nuclear reactor, that is deuterium oxide, heavy water. Okay, understand? So isotope of hydrogen reacts with oxygen to give heavy water. Okay, D2 plus O2 gives 2D2O. And then the second point, the A adds on to a compound C which has the molecular formula C3H6. Okay, so this is the molecular formula C3H6 compound C, CH3, CH double bond CH2. So when A react with this compound, A add this compound to give compound D. Okay, so A means D2 plus CH3, CH double bond CH2 gives CH3, CHD. Okay, deuterium here added here. Okay, here in this position. Okay, CH3, CHD and CH2D. Okay, this is the compound D. So A means D2 deuterium, B means D2O, that is heavy water or deuterium oxide, C means CH3, CH double bond CH2 propene, and D means CH3, CHD, CH2D, propane deuteride. Okay, propane deuteride. And question number 40. The ammonia means NH3 has exponentially high melting point and boiling points as compared to those of the hydrides of the remaining element of group 15. Explain. Answer. NH3 has higher boiling and melting point compared to all other hydrides of group 15 elements due to intermolecular hydrogen bonding. Okay, so ammonia has higher boiling and melting point compared to all other hydrides of group 15 elements due to intermolecular hydrogen bonding. You know, ammonia can form intermolecular hydrogen bonding with other molecules because of this. So ammonia has higher melting and boiling point. And question number 41. Why interstitial hydrides have a lower density than the parent metal? Why interstitial hydrides have a lower density than the parent metal? Answer. Metallic hydrides or industrial hydrides are less dense than the parent metal. Metallic hydrides or industrial metallic hydrides means titanium hydride. Okay, and mercury hydride, lead hydride, So metallic hydride, metallic hydride how form the interstitial position hydrogen will occupy. Okay, so metallic hydrides or interstitial hydrides are less dense than the parent metal. This is due to the slight expansion of the lattice during the formation of their hydrides. When hydrogen atom occupy the interstitial position of the metallic hydride, so a slight expansion of lattice takes place. The slightly expansion takes place in the metallic crystal. That's why it is less denser than parent metal. Understood? And question number 42. How do you expect the metallic hydrides to be useful for hydrogen storage? How do you expect the metallic hydrides to be useful for hydrogen storage? Answer. In some of the transition metal hydrides, hydrogen is absorbed as hydrogen atom. Due to the inclusion of hydrogen atom, the metal lattice expands and thus become less stable. Therefore, when such metallic hydrides is heated, it decomposes to release the hydrogen gas and very finely divided metal. The hydrogen evolved in this manner can be used as a fuel. Thus, transition metal or their alloys can act as a sponge and can be used to store and transport hydrogen to be used as a fuel. Okay, this is the 42 question. And 43. Arrange NH3, H2O and HF in the order of increased magnitude of hydrogen bonding and explain the basis for your arrangement. Answer. The order of increased magnitude of hydrogen bonding is ammonia. It is ammonia less than H2O less than HF. Strength of hydrogen bonds depend upon the atomic size and electronegativity of the other atom to which hydrogen is covalently bonded. Okay, strength of hydrogen bonds depend upon the atomic size and electronegativity of other atom to which hydrogen is covalently bonded. Smaller size and higher electronegativity favor hydrogen bonding. Okay, if the elements having the smaller size and higher electronegativity, it favor the hydrogen bonding. Among nitrogen, fluorine and oxygen, the order of electronegativity is fluorine, it is greater electronegativity than oxygen, and oxygen is greater electronegativity than nitrogen. Hence, hydrogen fluoride will have highest magnitude of hydrogen bonding because fluorine is most electronegative and it is the small in size. Okay. And question number 44. Compare the structures of water and H2O. Compare the structures of water and H2O. Here, structure of water and structure of H2O. H2O has a bend structure. H2O has a which structure? Bend structure because of the polarization. Okay, because of the polarization, H2O has a bend structure. H2O2 has a open book like structure. H2O2 has a open book like structure, And second point, the HOH bond angle 104.5 degree. HOH bond angle 104.5 degree. But the hydrogen oxygen bond angle is 94.8 degree and dihedral angle 115.5 degree in gaseous phase. And third point, it is a polar molecule. This is the hydrogen structure. It is the polar molecule. Okay, polar means the positive and negative charges occur in same molecule. Okay, and H2O2 has a non-polar molecule. H2O2 has a non-polar molecule because of the lone pair of electron present in the oxygen bond. Okay, understood? Repulsive force having here, because of this it is a non-polar molecule. Understood? The structure of H2O2, this is correct, it is not correct. So you can refer page number 112. You can refer page number 112 and draw the structure. Okay students, so we completed the book back question for the hydrogen compound, and tomorrow so today in Zoom class I will mark the book inside question. Okay, everyone should attend the Zoom class and ready to mark the questions. Okay, understood? And then we are going to unit number 3, periodic classification of elements. Unit number 3, periodic classification of elements. Okay, so what is the first question? Define modern periodic law, page number 73. define modern periodic law, page number 73, take now. 73, the second paragraph, third line onwards. The physical and chemical properties of the elements are periodic functions of their atomic number. Up to here you have to mark. The physical and chemical properties of the elements are periodic functions of their atomic numbers. Okay, and 25th question, it is not having the book, so we have to write a note. Okay, so 25th question, what are isoelectronic ions? What are isoelectronic ions? Give example. Answer, ions of different elements having the same number of electrons are called isoelectronic ions. Ions of different element. For example, this is the isoelectronic ions. Okay, this is the different ions. Sodium plus, Mg2 plus, Al3 plus, F minus, O2 minus, and N3 minus. Okay, so these ions of different elements having the same number of electrons. Okay, for example, so the sodium, you know, sodium atomic number 11. Okay, sodium atomic number 11. So sodium plus means, Na plus means 1 electron it lost. Okay, so how much electron it get? 10. Okay, understood. And the magnesium, you know, magnesium atomic number 12. So when magnesium it lost 2 electron, magnesium 2 plus means it lost 2 electron, it get 10 electron. Okay, aluminum 3 minus 3 plus means aluminum atomic number 13. So when it lost in 3 electron from the outermost orbit, it get the 3 plus, aluminum 3 plus, and what is the electron, number of electron? 10. Like that, fluorine minus means fluorine atomic number 9. So how much fluorine? 9 minus means 1 electron extra having here. So how much number of electron? 10 electron. So when it gain 1 electron from any other atom, so it form F minus. So number of electron 10. Like that, oxygen atomic number 8. So electronic configuration 2, 6. Okay, so for getting stable electronic configuration, it gain 2 electron from any other atom, so it becomes O2 minus. Okay, understood? So what is the electron? 10 electron. Like that, nitrogen atomic number 7. So electronic configuration 2, 5. So it needs 3 electron. When it gain 3 electron from any other atom, it becomes 2, 8, and total 10 electron. Okay, so these elements we call as the isoelectronic ions, because ions of the different element having the same number of electrons are called the isoelectronic ions. And question number 26, what is effective nuclear charge? What is effective nuclear charge? Page number 80. Page number 80. Take now page number 80. Effective nuclear charge. The repulsive force between the inner cell. The page number 80, right side of the page, third paragraph, fourth line onwards. Last paragraph. Okay, page number 80, last paragraph. The net nuclear charge. What is the effective nuclear charge? The net nuclear charge experienced by valence electron in the outermost shell is called the effective nuclear charge. It is approximated by the below mentioned equation. Effective nuclear charge, ZFF is equal to Z minus S. Here Z means atomic number. To here you have to mark. Z means atomic number and S means screening constant. Okay, up to here you have to mark. And question number 27. Is the definition given below for ionization enthalpy is correct? Is the definition given below for the ionization enthalpy is correct? What is the definition here? Ionization enthalpy is defined as the energy required to remove the most loosely bound electron from the valence shell of an atom. Okay, it is correct or not? It is not correct. Okay, you should write near the question. No, it is incorrect. The correct definition is no, it is incorrect. No, it is incorrect. The correct definition is page number 84. Page number 84, take now. Page number 84. The correct definition, ionization energy definition. It is defined as the minimum amount of energy required to remove the most loosely bound electron from the valence shell of the isolated neutral gaseous atom in its ground state. This is the correct answer. Okay, but in your question having the amount of energy required to remove the most loosely bound electron from the valence shell of an atom. Okay, this is not correct. So this is the correct one. And question number 28. So magnesium loses electrons successfully to form Mg2 plus, Mg plus, Mg2 plus and Mg3 plus ions. Which step will have the highest ionization energy and why? Okay, magnesium loses successfully to form Mg2 plus. When magnesium atom it losing one electron, it becomes the Mg2 plus. So ionization energy indicated by IE1. Okay, and then Mg plus, this Mg metal cation, okay, metal unication, it is again ionization. Okay, ionized to form Mg2 plus. Mg2 plus. Okay, it lost one electron, it becomes Mg2 plus. Okay, so ionization energy indicated by the IE2, second ionization energy. And then Mg2 plus again lost one electron to become Mg3 plus. Okay, so here ionization energy indicated by the IE3. Okay, so here what is the question here? Which step will have the highest ionization energy? Which step? This is the step 1, step 2, step 3. The third step will have the highest ionization energy. Third step will have the highest ionization energy. This is the decreasing order of ionization energy will be IE3. It is greater than IE2, greater than IE1. So IE1, the first ionization energy it is very low ionization energy. Why? Because from the neutral gaseous atom, the electron removal is easy and less amount of energy is required. Okay, this is the magnesium, this is the neutral atom. Okay, neutral atom means what is the magnesium atomic number? Mg. So electronic, how much? 12, atomic number 12. So electronic configuration 1s2, 2s2, 2p6, 3s2. Okay, 3s2. So this is the from neutral atom magnesium. The electron removal is easy. Okay, easily we can easily remove the electron. So it need less amount of energy. Okay, so Mg2 plus consists of 10 electrons. Mg2 plus means Mg2 plus consists of 10 electrons. So electronic configuration 2,8 attaining the stable gas configuration of argon. Okay, so when and the second ionization energy Mg plus, it again lost one electron to form Mg2 plus. So in the second ionization energy also, when compared to first ionization energy, it will be large amount of energy it need. Okay, but in the second ionization energy, it get the stable configuration, that is stable 2,8 configuration. Okay, nearest noble gas, that is argon configuration it got. Okay, and after getting the stable configuration Mg2 plus ion, it easily does not remove the electron because it is stable now. Okay, so if we remove the electron, if we again remove the electron from the Mg2 plus ion, it need more energy. Okay, it need more energy to remove this one electron from the Mg2 plus ion. Okay, because it is stable now. So what is the fourth point? The valence orbital is completely filled. So the removal of electron in Mg2 plus ion becomes highly difficult and more energy is required. Understood? This is the 28th question. And what about the 29? Define electronegativity. Define electronegativity. Page number 87. Page number 87. Page number 87. Define electronegativity. It is defined as the relative tendency of an element present in a covalently bonded molecules to attract the shared pair of electrons towards itself. It is defined as the relative tendency of an element present in a covalently bonded molecule to attract the shared pair of electron towards itself. That is called electronegativity. Understood? And the question number 30. Question number 30. How would you explain the fact that the second ionization potential is always higher than first ionization potential? How would you explain the fact that the second ionization potential is always higher than first ionization potential? Page number 84. So here the answer is the total number of electrons are less in the cation than the neutral atom, while the nuclear charge remains the same. Therefore, the effective nuclear charge of the cation is higher than the corresponding neutral atom. Thus, the successive ionization energy always increasing in the following order. Okay, what is the question? Second ionization energy, why greater than the first ionization energy? Okay, so we know about the ionization energy, minimum amount of energy required to remove the most loosely bound electron from the valence shell of the isolated neutral gaseous atom in its ground state. Here, for example, one of the element, element that is, when it remove the one electron, first ionization energy IE1, and it becomes M plus. Okay, M plus. So here the number of electron here low, but number of proton, the same proton having. Okay, no less the number of proton. So nuclear charge will be higher there. Okay, that's why after removing one electron, greater nuclear charge is having there. So nuclear charge it pull because of the greater nuclear charge, it pull towards the outermost electron. Okay, so it cannot easily remove the, again it cannot remove the electron from the outermost orbit. Okay, so the total number of electrons is less in the cation than the neutral atom, while the nuclear charge remains the same. Nuclear charge remains same. Okay, but number of electron low. Okay, so because of the effective nuclear charge, the cation is higher than the corresponding neutral atom. Understood? And question number 31. Energy of an electron in the ground state of the hydrogen atom is, energy of an electron in the ground state of the hydrogen atom is minus 2.8 into 10 power minus 18 joule. Calculate the ionization enthalpy of atomic hydrogen in terms of kilojoule per mole. Energy of an electron in the ground state of the hydrogen atom is minus 2.8 into 10 power minus 18 joule. Calculate the ionization enthalpy of atomic hydrogen in terms of kJ per mole. So here the given value E1 is equal to minus 2.18 into 10 power minus 18 joule. Okay, so E1 means ionization energy. Okay, so it is in ground state. It is in ground state. When a neutral atom, it is in ground state. That is a hydrogen atom. It is in ground state. What is the energy? Minus 2.18 into 10 power minus 18 joule. So when it becomes the excited state here, it is not an excited state. So E infinity, it indicates the excited state. E infinity, it indicates the excited state. So excited state here 0. Okay, excited state 0. Okay, so the energy change, that is E infinity minus E1. E infinity minus E1. So E infinity here 0 because it is in still ground state. So E infinity 0. 0 minus, what is the E1 value? Minus 2.18 into 10 power minus 18 joule. So minus and minus cancel. So we get 2.18 into 10 power minus 18 joule. Okay. So here our question, calculate the ionization enthalpy of atomic hydrogen in terms of kilojoule per mole. Okay, we should convert here joule into mole. Okay, we should convert into mole. So we should apply here mole concept. Mole concept here, there is 1 mole is equal to, mole means it is the unit, one of the unit, IUPAC, one of the SI unit of atom is mole. Okay, so 1 mole is equal to 6.023 into 10 power 23. This is the value, 1 mole value. Okay, we know the 1 kilogram is equal to 1 kg is equal to 1000 gram. Okay, like that. 1 mole is equal to 6.023 into 10 power 23. So ionization energy per hydrogen atom 2.18 into 10 power 18 joule. So ionization energy per mole of hydrogen atom. Per mole means 1 mole of hydrogen atom. Here 2.18 into 10 power minus 18 joule into per mole. Every per mole 6.023 into 10 power 23 atoms are having for the hydrogen atom. Every per mole, what is the value? 6.023 into 10 power 23. Okay, so 2.18 into 10 power minus 18 joule into 6.023 into 10 power 23. So when we are multiplying these two, we get 13.13 into 10 power 5 joule per mole. Understood? This is the 31 question, 31st question, and 32. The electronic configuration of atom is one of the important factors which affect the value of ionization potential and electron gain enthalpy. Explain. The electronic configuration of atom is one of the important factor which affect the value of ionization potential and electron gain enthalpy. Explain. Answer. The electronic configuration of an atom affects the value of ionization potential and electron gain and electron given enthalpy. Okay. For example, beryllium atomic number 4. So electronic configuration 1s2 2s2. So it is completely filled electronic configuration. Understood? So nitrogen atomic number 7. So electronic configuration 1s2 2s2 2p3. 2p3 means 2px1 2py1 2pz1. So it is half filled configuration. Half filled. 3p orbitals are halfly filled. Okay, so here the both beryllium and nitrogen have high ionization energy due to more stable nature. Okay, beryllium, it is the completely filled electronic configuration. Nitrogen is the half filled electronic configuration. We know completely filled. Okay, when an atom is completely filled means it is difficult to remove the electrons from the completely filled. Stable. Completely filled means it is unstable. Okay, if we are disturbing the stability, we should give the energy. Okay, we should give the energy. Here, so electronic, what is the question? Our question, electronic configuration of atom is one of the important factor which affect the value of ionization potential and electron gain enthalpy. Electronic configuration of an atom affects the value of ionization potential and electron gain enthalpy. Why? What is the reason? So when electronic configuration, we are writing electronic configuration, beryllium, for example, beryllium atomic number 4, electronic configuration 1s2 2s2. So it is completely filled configuration, it is stable configuration. So if we are removing one electron from the beryllium, outermost electron of the beryllium atom, we should give more energy to remove. Okay. So, and what is the fourth point? The electron affinity, about the electron affinity, electron gain enthalpy. Okay, so electron affinity or electron gain enthalpy of beryllium and nitrogen will be 0. Electron gain enthalpy, what do you mean by electron affinity? Electron affinity or electron gain enthalpy means amount of energy released. Okay, amount of energy released when electron is added to the valence shell of an isolated neutral gaseous atom in its ground state to form its anion. So we know the beryllium and magnesium, beryllium and nitrogen, beryllium is completely filled and nitrogen is half filled. Okay, so if we are adding the electron to the beryllium and the nitrogen, no need to add because already it is stable. Okay, so the electron affinity means the amount of energy released when an electron is added to the valence shell. So here no need to add the electron in the valence shell. So electron affinity will be 0 here. Okay, so because the addition of extra electron will disturb the stability, because when we are adding the extra electron will be disturb their stability or stable electronic configuration, it will be disturbed. So noble gases have the stable NH2 NP6 configuration and the addition of further electron is unfavorable and they have 0 electron affinity. Okay, like that the noble gases we know stable. Okay, all the noble gases it ends with NH2 NP6 configuration. So if you are adding further electron, it is unfavorable for the noble gases. So electron affinity here 0. Okay, Next, these are about the 32 question and 32nd question. The electronic configuration. So 33 question. In what period and group will an element with Z atomic number, Z means atomic number 118 will be present? In what period and group will an element with atomic number 118 will be present? Here, atomic number 118. Okay, if you see the periodic classification table, this is the atomic number 118, oganesson. What is the name of this element? Oganesson, Og, symbol Og. Which group this present? Group number 18. Okay, and which period? Period number 7. Okay, understood? So here the element with atomic number 118, the element with atomic number 118, it is present in 7th period and 18th group. 7th period and 18th group. Okay, you have to write near the question. And question number 33. Question number 33. Justify that the 5th period of the periodic table should have 18 elements on the basis of quantum numbers. Justify that the 5th period of the periodic table should have 18 elements on the basis of quantum numbers. Okay, so here, so quantum number, you know about the quantum number. How much quantum numbers are there? N, L, M, and S. N means principal quantum number, L means azimuthal quantum number, M means spin quantum number, and M means magnetic quantum number, and S means spin quantum number. Here N means principal quantum number. It represents the periods. Okay, N is equal to 1 means first period, N is equal to 2 means second period, N is equal to 3 means third period, N is equal to 4 means fourth period, N is equal to 5 means fifth period. Okay, understood? So here when N is equal to 5 means it is fifth period. Okay, so N is equal to 5 here. What is the L value? You know, N is equal to 5 means, what is the formula? We are getting the L value, N minus 1. N minus 1. Okay, so when N is equal to 1 means, when we are writing the integral values of L means, there is N minus 1. So N is equal to 5. 5 minus 1 is equal to 4. Okay, so L value here, totally 5 values are here. Okay, so how, when we are writing L value, it starts with 0 to N minus 1. Okay, 0 to N minus 1. So here N is equal to 5 means L value 0 to N minus 1. Okay, 0 to N minus 1. So N minus 1, 5 minus 1 is equal to 4. So we can write L value 0, 1, 2, 3 and 4. This is the L value. Okay, so according to Alpha principle, in order which the energy of available orbital 4d, 5s and 5p. Okay, according to Alpha principle means, what do you mean by Alpha principle? You know about the Alpha principle. What do you mean by Alpha principle? The atoms, Alpha principle means in a ground state of the atoms, the orbital are filled in the order of their increasing energies. Okay, this is the Alpha principle. So this is the increasing order of energy. First 1s and 2s 2p and 3s 3p, and then 4s 3d and 4p, 5s 4d. Okay, so this is the order. First 5s and then 4p, after that 5p. Okay, so 5th period elements, totally how much elements? 18 elements. So here this is the outermost electronic configuration. Okay, outermost electronic configuration, 4d, 5s, 5p. It increases in 5s, 4d and 5p. This is the increasing energy level according to Alpha principle. Okay, first 5s come and then 4d and then 5p. Understood? So here, how much 5s orbital totally? One 5s orbital. S orbital mean only one orbital. And 5 4d orbital. 4d orbital, how much? D orbital means how much orbitals? 5 orbitals. Okay, d orbital. So how much? 5 4d and 3 5p. P orbital, how much? Totally p orbital. Totally 3 orbitals there in p orbital. Okay, so totally 3 subshells are having the p orbital. Okay, understood? So here, this box no need to write, for understanding only I written this. Okay, so when n is equal to 5, l is equal to 0 1 2 3, and according to Offa principle, the order in which the energy of available orbitals 4d 5s 5p increases in 5 years, it is less than 4d and less than 5p. Okay, so first 5s and then 4d and then 5p. So how much s orbital? 5s means only one s orbital. 4d orbital means totally 5 4d orbital. P orbital means totally 3 5p orbital. Okay, so the total number of orbitals available is 9. Total number of orbital is available is 9. Totally how much orbital? S orbital 1, d orbital 5, and p orbital 3. So 1 plus 5 plus 3, 5 plus 3, 8 plus 9, 8 plus 1, 9. Totally 9 orbitals are available here. Okay, so for 9 orbital, maximum number of electrons that can be accommodated is 18. Each orbital accommodated, we can accommodate 2 electrons. Okay, so therefore 18 elements are there in the fifth period. Therefore the 18 elements are there in the fifth period. Okay, we know the in period, so okay, see the periodic table here. This is the fifth period elements. Fifth period. Okay, fifth period elements here. In fifth period, it starts from rubidium to xenon. So outermost orbital here, rubidium to xenon, outermost orbital, it is occupying 5s, 4d and 5p. It ends with 5p. Okay, it starts with 5s1 to ends with 5p6. Okay, so this is the d transition elements. It have the d orbital. In transition element has the d orbital. Understood? So this is the this is the fifth group elements. The fifth group elements, outermost electronic configuration, that is s orbital, d orbital and p orbital. Okay, totally how much electrons we can accommodated in the fifth period elements? Totally 18 electron we can accommodated. So 18 elements are there present in the fifth period elements. Okay, students, this is about the 34th question. And 35th question here. The elements A, B, C and D have the following electronic configurations. Elements A, B, C and D. Here A, B, A. Okay, it's electronic configuration 1s2 2s2 2p6, and B 1s2 2s2 2p6 3s2 3p1, C 1s2 2s2 2p6 3s2 3p6, and D 1s2 2s2 2p1. Okay, so what is the question here? Which elements among these will belong to the same group of periodic table? Which elements among these will belong to the same group of periodic table? Okay, so here we know in every group having the same electronic configuration. Every group having the same electronic configuration. Okay, so here the electronic configuration, it ends with 1s2 2s2 2p6. Okay, A, for A 1s2 2s2 2p6, and here also C also 1s2 2s2 2p6 3s2 3p6. Okay, so this is the 18th group. 1s2 2s2 2p6, 1s2 2s2 2p6 3s2 3p6. This it belongs the 18 group. Okay, we see the periodic table here. This is the 18 group. So 18 group, it start with 1s2, and second period 18 group 2s2 2s1 2p6. After that 3s2 3p6. Okay, so this is the 1:2:2p6, it belongs to which group? Which element? 1:2:2p6 means neon. Okay, neon. And 1:2:2p6, 3:3p6 means it is the argon. This electronic configuration belongs to the argon. Okay, so these two elements, it belongs to the 18th group. 18th group. So A and C, it is the 18th group, and B and D. Okay, listen here. B and D, 1:B. What is the B electronic configuration? 1:2:2p6, 3:3p1. After that, D, 1:2:2p1. Okay, so if you are seeing the periodic classification, periodic table here. So this is the 13th group elements. Okay, 13th group elements. It ends with 3s2 and 3p1. Which one is the 13th group? This is the 13th group. So it ends with 3s2, 3p1. So aluminium, what is the electronic configuration? 3s2, 3p1 outer electronic configuration. And boron, 2s2, 2p1. 2s2, 2p1. Okay, so this 1:2:2, 2p6, 3s2, 3p1. Which element? Aluminium. Okay, for the electronic configuration for aluminium. And this is the electronic configuration for boron. Boron atomic number 5. So 2 plus 2, 4 plus 1, 5. Okay, so these two electronic configuration, it belongs to 13th group. Understood? And which what is the 36th question? Which give the electronic configuration of lanthanides and octanides? Give the electronic configuration, general electronic configuration of lanthanides and octanides. Page number 78. Take now page number 78. General electronic configuration for lanthanides and octanides. Page number 78. Third paragraph. The lanthanides 4F1 to 14, 5D0 to 1, 6S2, and the octanides 5F0 to 14, 6D0 to 2, and 7s2. This is the outer electronic configuration for the general electronic configuration for the lanthanides and the octanides. Okay, so up to here you have to mark, and the remaining questions tomorrow I will mark. Okay. Okay, students, today your assignment from unit 4, the 30 and 31st question. Okay, 30 and 31st, page number 123, question number 30 and 31. What is water gas shift reaction? 30, question number 30. And 31, justify the position of hydrogen in the periodic table. Okay, page number 101. You have to study and write the assignment and send me through my WhatsApp number. And next month you have the midterm examination. For the midterm examination, our portion unit 3 and unit 4. Okay, unit 2 already have been written in one exam. Okay, that's why for this midterm, unit number 3 and unit number 4 have to study the periodic classification of elements and then hydrogen. Okay, these two lessons. Book and question also have to study. For the 25 mark, 1 mark question. Book and question important. Book in and book back. Both book in and book back you have to study fully. Okay, and for the 2 mark and 3 mark question also, book in and book back question need to study. Okay, students, thank you.